Good afternoon, everyone. Can you please tell me what we have discussed in the last class?
So your voice is a little bit low.
Voice is low. Is it okay now?
Yes, sir.
Yes, sir.
What we have discussed in the last class? We have discussed about sample space and then event and these things.
Yes, sir.
Yes, sir.
So have I given you that definition of probability
Yes,
Yes,
sir.
sir.
and some properties of probability, some propositions?
Yes, sir.
Okay. So let me go next. Actually, this is also not working. These slides are also not working good. Things are getting automatically deleted when I'm saving them. So let me go to whiteboard only. Here actually writing is little bit easy. I feel comfortable here. Just this happens often that the pointer gets missing. That we can manage by reopening it each time. So we have discussed about this proposition. If you remember, if for any two event, okay, I have not shared the screen. Okay, wait. Yes. Is it visible now?
Yes, sir.
Yes, sir.
Okay. So for any two events, A and B. So if an A and B are any two events, then we have seen this property, that is A, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. That we have already seen, if you remember.
Yes, sir.
Okay. Then I have told you that this can be generalized to uh, any number of events. You can generalize it to 3 events. You can generalize it to 4 events. So suppose you have 3 events, A, B, and C. 3 events. Then you can generalize it as A union B union C equal to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of A intersection C minus probability of B intersection C plus probability of A intersection B intersection C. That we have already seen in the last class. Okay. So I have given the proof of this first one.
Yes, sir.
Yes. So let me discuss some examples, and I can say this is one of the important example. Probably this kind of problem will be asked in the P's as well as in the mid semester examination also. So problem is like a computer consulting, a computer consulting firm presently has bids out on 3 projects. So let AI is denoting event that awarded project 1. Project I actually. I am writing AI, so it's I, where I can be 1, 2, and 3. Got it? And suppose these probabilities are given. Suppose that, let me write here, probability of A1. A1 is if the event of getting first project awarded, A2 is the event that second project is getting awarded, and A3 is the third product is getting awarded. So PA1 is given as, this probability is given as 0.22. PA2 is given as 0.25. PA3 is given as 0.28, and probability of A1 intersection A2 is given as 0.11. Probability of A1 intersection A3 is given as 0.05. Probability of A2 intersection A3 is given as 0.07, and probability of A1 intersection A2 intersection A3 is given as 0.01. Got it? Now you need to compute some probabilities of some events. So compute the probability of each event. Okay. So the first event is A1 union A2. So you need to find the probability of A1 union A2. Next event is A1 days intersection A2 days. So probability of A1 intersection A1 days intersection A2 days that you need to find. Then the third event is A1 intersection A2 intersection, sorry, it's union. Back. A1 union A2 union A3. Then you need to find A1 days intersection A2 days intersection A3 days. Then you next need to find as A1 days intersection A2 days intersection A3. And one more is there, that is you need to find the probability of A1 days intersection A2 days union A3. So these are the 2, 4, 6 events for which you need to find the probability. So let me go to the solution part. Okay, so first is you need to find as probability of A1 union A2. Can you use this formula? This one, first one. This is probability of A1 plus probability of A2 minus probability of A1 intersection A2. You know the value of probability of A1. You can see here it is 0.22. Clear? Probability of A2 is 0.25 minus probability of A1 intersection A2 is 0.11. 0.11. Can you please give me the value?
0.36.
0.36. Let's see the next one. B. A1 dash intersection A2 dash. So we need the probability of this event. I'm giving you one formula, what we call as De Morgan's law. We call is De Morgan's law. It is A union B dash equal to A1 dash intersection. Sorry, A union B dash equal to A dash intersection B dash. This is the formula. So I am using this formula and I can write it as probability of A1 union A2 dash. Can I write like this? Using this formula?
Yes,
Yes,
sir.
sir.
Okay, so next you can write it as 1 minus probability of A1 union A2. Why? Because we have this formula. Probability of some event A dash equal to 1 minus probability of A, that I have already discussed. Probability of A plus probability of A dash equal to 1. So you can use this formula here. Probability of this event complement, this part, equal to 1 minus probability of this event, A1 union A2. So you can calculate it as 1 minus, what is the value of this? A1 union A2, you have just calculated 0.36. So value is 0.64, right?
Yes, sir.
Okay, so next is C, probability of A1 union A2 union A3. Can you use this formula? This one?
Yes, sir.
Probability of A1 plus probability of A2 plus probability of A3 minus probability of first two A1 intersection A2 minus probability of first and third A1 intersection A3 minus probability of second and third A2 intersection A3 plus probability of A1 intersection A2 intersection A3. Fine. There is A3 also. So you can calculate it as probability of A1, A2, A3 are given. So it is 0.22 plus 0.25 plus 0.28 minus 0.11 minus 0.05 minus 0.07 plus 0.01. You can compute these values, you can calculate it, and this value is going to be, anyone? Is it fine?
Yes, sir.
So this is the value of this probability of A1 union A2 union A3. So next is probability of next event is A1 dash intersection A2 dash intersection A3 dash. The same one happening. Next is, let's D. Event is A1 dash intersection A2 dash intersection A3 dash. So you need to find the probability of this event. Can you use the De Morgan's law again? A1 union A2 union A3 dash. So this can be written as 1 minus probability of A1 union A2 union A3. The second formula that I have used, probability of A plus probability of A complement equal to 1. So here you can get it as 1 minus, what is the value of this? We have just calculated
0.53.
0.53. So this will give you the value as 0.47. Fine. E. So E is A1 dash intersection A2 dash intersection A3. So you need to find this probability. So what I can do, I can give you a Venn diagram that will make you more clear about that. Let it connect here. So this is A1, A2, A3. Okay, so what I need to consider, A1 dash intersection A2 dash intersection A3. So A3 is this entire part. Let me color it by white. Okay. Then A1 dash is the outer part. Suppose this I can draw a sample space, entire sample space. Suppose this is geometric sample space. So A1 dash intersection A2 dash. A1 dash intersection A2 dash is the part which is actually, let me, this outer part. This whole outer part is A1 dash intersection A2 dash. So A1 dash is the outer part, A2 dash is the outer part. So its intersection is this whole outer part. Got it? And then I am taking intersection with A3. So this region is going to be the desired region. Let me take this region. This is the desired region. Got it?
Yes, sir.
So what we can write, you can see that we can write this part. We actually need this part. So this can be obtained by, suppose I am taking the whole minus this, and this is being counted twice. So one more time I have to subtract this. So let me, actually I have to add this. So this is going to be probability of A3. So probability of A3 is the entire A3. Now I need to subtract this part. So that is going to be minus A1 intersection A3. Anyone saying something? A3. So this part is excluded from A3. Similarly, if I take A2 intersection A3, this part is excluded. So minus probability of A1 intersection A2, this part is excluded. But this middle part, the common part, is being excluded in this intersection also and in this intersection also. So it is being excluded 2 times. So I have to add 1 time. That is probability of A1 intersection A2 intersection A3. So this is denoting this yellow shaded region. Got it?
Yes, sir.
So now, what is the value of this probability of A3? It is
Point two eight.
A3 is 0.28.
Yes, sir.
It's 0.28. Then minus A1 intersection A3 is
0.0.
let me one thing. Yeah, this is A1 intersection A3 and this is A2 intersection A3. A2 A3. Got it? Small correction. So A1 intersection A3 is 0.05 and this one is 0.07 plus this part is 0.01. You can calculate this value. This is going to be
0.41.
0. No, it will not be 0.41.
Oh, sorry, sir.
17, I think. Is it okay?
Yes, sir.
Okay. Next one is A1 dash intersection A2 dash and then taking union with A3. We need the probability of this. Let's go to the Venn diagram. So suppose you have 3 events A1, A2, A3. So A1 dash intersection A2 dash is the whole outer part except this. A1 dash is the outer part, A2 dash is the outer part. So intersection of this is going to be the whole entire part, this whole outer part. Got it? This whole outer part is A1 dash intersection A2 dash. And then union with A3. So union with A3 means this part, union means either this outer shaded part or A3 or in both. So both part is this part, in A3 part is this part and this is the. So actually it is going to be the entire outer part. Let me highlight it. Entire outer part plus this part, and of course whole outer part is also going to be included here. This whole part. Got it? You can color entire. This whole part is there. Okay. Got it? So how to write this? You can rewrite it as like, if we take suppose A1 into A1 dash, A2 dash and A3 dash, the intersection of all three. Complement of A1 dash, intersection complement of A2 dash, intersection complement of A3 dash. So this will be the whole outer part except these 3 circles. The region covered by these 3 circles except those part, the entire outer part will be like probability of A1 dash intersection A2 dash intersection A3 days, outer part is covered, and this part, this inner part is the just A3. So plus probability of A3. Will it be okay? This is the entire shaded region. So you already know this value. What is this value? This is 0.47 plus what is the probability of A3? 0.28. This one. This value is going to be 0.75. Is it clear?
Yes, sir.
So
Okay.
we can also apply the formula of P, like we can consider A1 dash intersection A2 dash as A, and then A3 as a B, and then we can use the formula of P A union B, like that formula that you gave.
Yes, you can consider the shaded region in different way also.
Okay, sir.
Okay. So one way is this one, what I have discussed. You may search for other way also, like what can it be? You can take the entire A3, or what you can do is this. You can take the A1 days intersection A2 days. A1 days intersection A2 days, this whole outer part, and then you can consider this A3 part. Yes, there are other ways you can select it. That's not a problem. But in any of the method, whatever you are using, you are actually going to get the same result. It's 0.75. I have told you many times that the value of probability is always going to lie between 0 to 1. Minimum 0, maximum 1. It cannot exceed these two limits. If you are getting negative values, or if you are getting greater than one value, then you are definitely doing wrong somewhere, and that's why you are getting that wrong result. Okay. So next is, suppose that we have one problem next. One more example is there. Suppose that 55% of all adults regularly consume coffee. 45% regularly consume carbonated soda, and 70% regularly consume at least one of these two products. At least one of these two products. So first question related with this is, what is the probability that a randomly selected adult, what is the probability that a randomly selected adult regularly consumes both coffee and soda. Coffee and soda. And second question associated with this is, what is the probability? What is the probability that a randomly selected as adult doesn't regularly consume at least one of these two products? Hope you can solve this. I'm just giving you some hint. Let A is an event denoting adult regularly consume coffee. And B is adult regularly consume carbonated soda, and you may consider or you may not consider. So we have, what are the things we have now? Probability of A is 55%, means 0.55. Probability of B is 45%, means 0.45. And probability of A, 70% regularly consume at least one of these, either A or B or both, either coffee or carbonated soda or both. So this is A union B equal to 0.70. Can you please find the first one? You know the formula. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. You can rewrite, you can take this to left side and this to right side, because you need, what is the probability that a randomly selected adult regularly consume both? Both means A and B. Intersection means and. So it is probability of A intersection B equal to probability of A plus probability of B minus probability of A union B. You have all these values. Probability of A is 0.55, probability of B is 0.45, minus probability of A union B is 0.70. You can calculate this value. This is going to be
0.30.
0.30. The second one is calling as that probability a randomly selected adult doesn't regularly consume at least one of these two products. Means what? You can say the same event as the adult consumes only carbonated soda or doesn't consume both products, or the selected adult consumes only coffee or consumes only carbonated soda or doesn't consume both products. Means it's like saying probability probability that A intersection B dash either consumes A only, means this first one, plus B or A dash intersection B, only B, plus not both, A union B dash. So this is the scenario. Actually, you can understand it by this. A, this is B. So A union B dash. A union B is this entire part, either in A or B or in this common part. So A union B dash is the whole outer part. What? This one. And then only A, not B. So that one is this region. Only B, not A. That one is this region. So this is the region to be covered. So this probability, you can see this and the outer part are actually mutually disjoint. So you can get this probability as probability of A intersection B dash plus probability of A dash intersection B plus probability of A union B dash. You can see this formula. Suppose A intersection B dash. If I want this blue shaded region, so this is total A minus this intersection part. So this probability of A intersection B dash is nothing but total A minus probability of A intersection B. This is, so I am writing for this as probability of A minus probability of A intersection B. Similarly for B, this is total B minus this intersection part. So this is total B, entire B, probability of B minus probability of A intersection B. Plus you already know that P A complement equal to 1 minus probability of A. So this is 1 minus probability of A union B. What is probability of A? This is 0.55. Probability of A intersection B, where it is 0.30. 0.30 plus probability of B is 0.45 minus probability of A intersection B is 0.30 plus 1 minus A union B is 0.70. You can calculate this value. This is going to be, what is the value? Give me the value.
0.7 final answer.
0.70 final answer. Okay, so this is how you can get these probabilities. Let me go to,
Sir,
yes,
sir, I have a doubt in this last part.
in this slide.
Yes, sir.
Okay. Let me go then again. Wait a moment. Yes.
Sir, at least once means A union B, right?
Huh?
At least one means A union B.
At least one. Yes, at least once मतलब या तो A में, या तो A में मतलब क्या, या तो कॉफी पिएगा या तो कार्बोनेटेड सोडा पिएगा या दोनों पिएगा. तो एटलीस्ट का मतलब वो हो गया.
That means at least one is A union B. And
Yes, A union B.
if we write doesn't at least one, not at least one, so it should be 1 minus A union B.
So actually, this statement that a randomly selected adult doesn't regularly consume at least one of these is same as saying like uh, you can say it as the selected adult consumes only coffee or consumes only carbonated soda or doesn't consume both products. It's actually the same statement. So if you try to match these two, then only you can understand that both are actually same.
So
If you want, I can
thought,
write that.
no, I understood. Actually, I thought that
What
would
if?
be sample space minus the A union B. That could be the doesn't regularly consume.
No, I am writing that for that also the selected adult DULT adult consumes only coffee or consumes only soda or doesn't consume both. So this and this statement are exactly same, and that's what I use when going through this. If you can think in that way, you can go from there.
Thank you, sir.
Let me go to one more problem. Yes, this gets missing, so I have to close it, and then again I have to open it. Next is consider the type of cloth dryers. It may be gas dryer or electric. Purchased by each of 5 individuals. Or let me say each of 5 different customers. At a certain store. So first question associated with this is if the probability that at most one of these purchases, if the probability that at most one of these purchase an electric dryer, electric dryer is this probability is given as 0.428. At least, at most one purchase. मतलब या तो नहीं खरीदेगा या फिर एक आदमी खरीदेगा. Okay. एक electric dryer. Then you need to find what is the probability that at least, this time you can see this was at most one, this is at least two. At least two purchase an electric dryer. At least two purchase an electric dryer. So suppose I am considering that A is an event that at most one of these customers purchased an electric dryer. So if you think that saying at most one customer and then saying at least two, at least means 2, 3, 4, 5, because there are 5 customers, so two of them will buy electric, 3 of them will buy electric, 4 of them, 5 of them, like that. So actually this event A is just the complement of, we actually need A dash equal to 1 minus probability of A. We need to use this when these two events that at most one of these purchase an electric and at least two purchase an electric are actually complement. So this is going to be A dash equal to 1 minus probability 0.428. Okay, so this is 0.572. One more question is there with this, and that is let me check how many students are present. Only 59. So let me take attendance. I am leaving the half part of that question because I have 5-7 minutes. If you have any question, let me know first. Any question in this part?
No, sir.
Okay. So let me take attendance. There are only 60. And 11 that I have already taken. Let me mark that also. Otherwise. Zero 007 absent. 138
Present, sir.
171
Present, sir.
237
Present, sir.
273 308 534
Present, sir.
622
Present, sir.
652
Present, sir.
768
Present, sir.
1053
Present, sir.
1158
Present, sir.
1274,
Present, sir.
1510,
Present, sir.
it has increased to 65. Good. Where I was? 1153 done. 1158. 1158. 1274.
Present, sir.
1510.
Present, sir.
1533.
Present, sir.
1561.
Present, sir.
1565.
Present, sir.
1581.
Present, sir.
1596.
Present, sir.
1598.
Present, sir.
1599.
Present, sir.
1617.
Present, sir.
1746.
Present, sir.
1792. 1799.
Present, sir.
1821.
Present, sir.
1855. 1864. 1970.
Present, sir.
2016.
Present, sir.
2039.
Present, sir.
2040.
Present, sir.
2246.
Present, sir.
2406.
Present, sir.
2411. 2446.
Present, sir.
2461.
Present, sir.
Okay, done. 2605.
Present, sir.
2617.
Present, sir.
2637.
Yes, sir.
2649.
Present, sir.
2669.
Present, sir.
2673.
Present, sir.
2677.
Present, sir.
2679.
Present, sir.
2682.
Present, sir.
2683.
Present, sir.
709.
Present, sir.
Present, sir.
Who is this?
Sir, 2720.
2720. Okay. 2722.
Present, sir.
2725.
Present, sir.
2731.
Present, sir.
Okay, so rest all are present. I am giving attendance to all. Done. Fine. Thank you.
Excuse me, sir.
Thank you, sir.